This is a hard question, and I was a little bit surprised to see the cubic function. So I don't really know why that's in the exam, but I guess if it's there, they're expecting people to be able to deal with them. So the question is there a positive value of t for which r is 0? So if you think about this cubic function, we're only looking at this region here, the positive, and this is t. And if we plot the function r, this is our y-axis, that if we plot this cubic function, could it look like this? Because here, t is a positive value for which r is 0. So they're really just looking for that yes or a no. So we'll start with statement 1, says a is greater than b. So we can think with numbers, and what I'm going to try to do is to do a yes and a no. So let's say a is 0, because I really want to get rid of that cubic part. B is minus 1. So then r is minus t squared plus, let's say c is 9. So you'll notice that minus t squared plus 9 can be equal to 0, and a positive value of t in this case would be 3. So we'll say, is there a positive value? The answer would be yes. But could it be no as well, meaning where there is no positive value? So what we're going to do in that case is, let's say, A is 1, B is 1, and then C is also 1. So our function would be t cubed plus t squared plus 1. Now, we're looking at only positive values of t, and you'll notice that this will always be positive. In fact, will be greater than 1. So there will be no value of t for which this will be equal to 0. So that would answer the question as a no. So 1 alone is insufficient. If we look at 2 alone, is saying c is greater than 0. Well, the 2 examples we used, we can use them again, because in both cases, c is positive, and I can use anything for a and b, and we'll have our yes and a no with those same examples. So 2 alone is also insufficient. If you combine 1 and 2, I can again reuse these examples, because they will satisfy both of these statements, and I'll have a yes and a no. So I think this is to keep in mind that in a lot of the data sufficiency, you can use the information again. But of course, you have to be careful not to bring, some preconceived examples that you can also fall in traps. But in this particular case, it was helpful that whatever examples we used here do apply even when we combine 1 and 2, and the answer is E.